tonight. Alex Zelinsky, furthest from me, is Australia's Chief Defence Scientist, which means he heads the Defence Science and Technology Organisation and is the Deputy Secretary in the Department of Defence. Before that, he was on the executive of the CSIRO, and before that, he was one of us. He was a professor in the then Research School of Information Sciences and Engineering, where he founded the company called Seeing Machines. Hans Bachor here is an Emeritus Professor here at the university. He was the former Director of the university's ARC Research Centre for Quantum Atom Optics. And he's a quantum mechanics person, so you only see 99.9% of him here. The other 0.1% is somewhere else. He's demonstrated teleportation in his time as a quantum mechanics person and is now a consultant in physics and in science education and science communications. So colleagues, with that introduction, we're going to go straight into questions. And the questions are going to be addressed first to Alex and then to Hans. And the first question is, what makes a good research problem? Alex.
Well, that's a great question. Thank you, John. And firstly, let me apologise for mucking around your schedule today. It was an unexpected appointment from the Minister, which forced me to be here an hour later than I intended. So thank you for accommodating me today. So what makes a good research problem, was it? A research question, you say?
Mm-hmm. Good problem.
Yes, problem. Look, I think one of the things, you've got to be passionate about what you're looking into. Without passion, you can't do anything. So that means to get that passion behind, or an interest, an intense interest. And the next bit, I would say, for me is that it's got to be some sort of challenge to it. You know, it's hard to do. And the third element, I would say, is that it makes a difference. So you've got to improve humanity, solve a fundamental challenge, which is limiting maybe productivity, or it could actually be, I'm a technologist by nature, so I'm looking at those sort of things that will actually make a positive difference for society or humanity, and maybe even make an economic difference. So it's something with a purpose. So that would be
short term or the long term?
Well, it could even be long term. Right. So you can have a long term challenge, but the point is, if it was easy to do, someone would have already done it. So it's got to be sort of the technical aspect to it. But then also you've got that passion to it's like climbing your own little Mount Everest.
Thank you. Hans, what makes a good research problem?
Well, Alex said quite a few of the things that apply to my vision as well. But let me be a bit more on the time scale. I think a good problem has to be visionary. So there has to be something 10, 15, 20 years down the track that makes this contribution. It could be a short-term problem, but good ones, I think, have a long-term phase. But you also have to be realistic what you could achieve in the next 3 or 4 years. So when you actually propose the work and tell people about it, I think it has to have these two components. The passion, I think that's almost a given, because if you don't have the passion, you wouldn't succeed. But you also have to be aware what is the best technology that you could use now, and even take a guess what the technology might be in 3 or 4 years' time. So you're not trapped in some outmoded way of doing it. So vision, realistic, latest technology would be on my list.
Is there a difference between a good research problem for a practicing researcher and a PhD student?
That's a good question. I think that sometimes you can start on a quest, and the PhD is just an instalment. And when I got started, I got very interested in robotics, and the PhD was just a way to get that, almost like a driver's license, to get the skills that you could actually climb your own Mount Everest, so that sort of aspect. So it's a way to actually, and you start actually exploring and understanding what are all the issues about being a great mountaineer to climb these challenging intellectual problems, and that you're setting yourself. So I think and in the course of that, you actually have to climb a part of that mountain. So I think and then you may choose, some people then, while they're climbing that mountain, may then decide to give themselves another mountain to climb, and you keep challenging the challenges. But I think PhDs it's a step in the quest.
Okay, so being able to look back now, what do you know now that you wish you knew when you first started?
Ooh. I think that when I reflect on this, I just think that I didn't set my goals high enough or wasn't ambitious enough in some ways. Sometimes we start off and it goes back to your whole schooling or the way things are actually done in Australia. I think in a way we talk to our kids and things like that. We give them the aspirations to be a great potential sportsman or a sportswoman, do great things in physical types of challenges, but I don't think we actually say you could do much more intellectually, etc. And also that expectation. I've got it. The sort of the moment I realised that was when I was working here at the ANU. I had a small research laboratory in Brian Anderson's school there. We set up, and we decided to purchase this fairly advanced technology robotic arm, and it was from a spin-off company out of MIT. And MIT, as everyone would know, is one of the top universities in the world. And we wrote a grant. I think Brian gave me some money, and somehow we cobbled the money together and we got it. And I remember it broke down very quickly. And then we opened up the cabinet and looked inside, and I was just shocked at the low quality of the work and the technology. And what I realised was what was just limiting us was the idea of we could be doing this, and it's just the fact that you just somehow assume, well, this piece of kit has come from MIT, so it's got to be good, and we can't do that. So that actually got me thinking we should be able to start our own company, and that actually in the end led to Seeing Machines, which has gone on to do great things, and it's a world leader. It's only because we kind of realised we could be a world leader, but I was never really charged with that idea. It was really just being a good employee at the university, write papers, but having that ambition of doing something special and being absolutely outstanding and really seeking that and being told that you could do that from the beginning and being encouraged to do that is probably what's limited me. So I tell people here, reach for the stars and you might hit the moon.
Thank you. Hans, what do you wish you knew now?
Now, let me first fully agree with that. I think we're not challenging enough the intellectual capability of the people we have, the young people we have. We always tell them how great they are, but I think it's challenging is different, isn't it? It's about posing the challenge and then reacting to both, will they achieve it or not. But I like to add something else, and that is the observation from my perspective now, that in many situations, I was too optimistic about the progress I would make in a given time. So I would say, what can I do in a year, in 2 years, in 3 years' time? And then I was disappointed when we were not quite there. But then I was surprised how much the whole field had changed, let's say, on 5 or 10 years. So, the observation is when you're deeply involved, maybe frequently a little bit too optimistic, but when you try to predict big pictures and what the world would be like in 5 or 10 years' time, you're probably too limited by what we know now. So taking that into account, you can be really reaching for the stars and being bold in what might be possible in the long term.
But you're saying that whilst you reach for the stars, you shouldn't be too disappointed if it takes a long time to get there.
It takes longer, and we're probably all, for good reason, want to run faster than we technically can. That doesn't matter. There will be a detour, there will be suddenly a new event, a new technology, a new insight, and then we make a big leap, and nobody has seen it, or very few have seen it.
Alex?
I actually agree very much with Hans's comments, and in fact, you have that, you reach for the stars, and that ambition, you generally underestimate how hard it is. If you knew how hard it might be, you might not do it. So it's kind of that optimism that takes you forward, and it takes you maybe longer, and there may be setbacks on the way, but generally, even still, if you're actually the first person trying to climb this mountain, I'm sorry using that same analogy here tonight, but it does give you, you're still ahead of the rest, and if you are truly branching out into new areas, even though your progress may appear to be small and you haven't reached where you'd like to be, you're still ahead of the rest, and you still feel like you're at the forefront. And I think that's when it's frustrating, is if you actually fall behind or you don't have the resources to keep up and you can see people going past you. I think that can be disheartening. But if it's long and arduous, but you're still leading, it's okay.
Or if someone overtakes you think about it and change tech, right?
That's right.
That could also be. Don't persist with your path if
That's
something
right. You've got to change.
bigger has happened and there are better ways of doing it.
Well, then my PhD supervisor told me that any good PhD student gets depressed twice a year. You know, the work...
No, it's more often than that.
So, Alex, with that background, what motivates you?
Oh, look, I think it goes back to that first answer, partly to the first question, which is making a difference. I think I've always been a person who's, you know, while it's important, when I was here at the university, I sort of wanted to write quite a number of high-impact papers, and I wrote 100 papers, and I got good papers, and you get the citations, and that's a form of getting impact. But then I really wanted to realise that my work wasn't having an effect on society or changing the world. And then you kind of see some of these guys like the Google guys who just started up, you know, around the time in 1989 or 1988 and 99 when I was here at this campus working, and within 18 months they created this sort of revolution, and you think, wow, that's important. And it was based on some interesting technology, some research that they had started at Stanford. But that made me think that I really wanted to do things which actually made a difference. And then we went into the company, we got the company working and all the rest of it, and I kind of understood why it's important to have products, and you've got to be able to sell your product and make it useful. But the product could be very underlined by very strong research results. And after a period of time, I then realised that, okay, now this is commercial stuff, I'd like to get back into research, and working at CSIRO and at DSTO is kind of that national goal type stuff. We're kind of motivated by challenges of what's in Australia's national interest, working on problems like climate change or the impact of climate change and how you can mitigate that with new energy technologies or new ICT technologies, thinking about what we can do around water. And that all requires fantastic breakthroughs in basic science, applied science, and then thinking how you can then translate it for use.
So with your engineering background, that will be a very logical answer to what motivates you, because you want to create and do things for society. From a scientist's point of view, is it the same motivation or something different motivate you, Hans?
In an abstract sense, it's very similar. I mean, what I see is actually the challenges we have. You mentioned one of them, climate, water, food, energy. It looks like the challenges are actually getting bigger, yes, and they're getting more urgent. And then you sit there as fundamental scientists and say, well, you know, should I do this? There's not enough time to do it. But I'm an optimist, it will. So I'm sitting at this interface between engineering and theoretical physics. My career was about building actual gadgets or machines that could demonstrate the sort of abstract ideas the theoreticians were painting. Mid-last century, 1930s, 1960s, quantum mechanics, apart from the part of making new materials, was very abstract. And then there were opportunities to actually demonstrate these effects. Now, I'm convinced that in our quest to make faster computers, faster communication, better energy sources, we'll hit these barriers within the lifetime of the audience, right? In 20, 30 years' time, there will be engineers who need to know quantum mechanics just to build a machine, because you only have a few electrons in a circuit, or you have a few photons in a communication line, or you have pushed some energy technology to its limits. And that motivates me. You know, there's a real frontier out there where the ideas which we were dealing with will be the mainstay of the people who design new machines.
And so, Hans, you tell yourself that while you're working on what we might call pure research problems, that there will ultimately be some benefit to humanity somewhere down the line. Absolutely. Might be 30 years away.
Yeah, people will pick it up, engineers will pick it up, designers will pick it up, and it will become an essential component of what we need to do to address these challenges.
I often look at the mobile telephone and think that the only reason that works is that the pure scientists developed the quantum mechanics that made the transistors and the electrochemistry that makes the batteries and the displays and so on. And then the engineers somehow package that together into something which is manufacturable and not quite usable until the computer scientists get hold of it. The computer scientists then embed the software, and you've got this 3 layers of development from the pure through
the features in there which we didn't know how to do in your iPhone, we didn't know how to do 10 years ago. There are structures in there that were too small to manufacture or too reproducible, materials that are too pure, we didn't have them. And they all came together. Now, I don't know whether the iPhone solves all our problems, but you know, it's a good example.
Thank you. What doesn't work? Like, Alex, what didn't work for you in research?
What doesn't work? I think one of the things you've got to... I've been sort of fortunate when I look back on things over the last 10, 20 years is really, it's actually working with people. That's where, you know, I've realised it's one of the other important points is that even though we are, when in research, it's about the individual, you get your PhDs, your papers, your awards, your grants, but actually it's very hard, certainly in the areas I've worked, to individually do it and to be the sort of well, you can lead, but you still really rely on teams. And I think that I've actually valued very much more the people around me or work with me and the people who can actually learn to work in a team, because it's at the end of the day, most of the innovations we'll see going forward are team-based. You just used the example, Hans, of the mobile phone. That could not be done by one person, with even a person with his own laboratory. You really need teams, and large-scale teams, multidisciplinary. And that's going to be the key, I think. And I think that we've, in the past or recent past, we haven't really emphasised that in our training of young scientists, is that you are going to be a member of a team. And invariably, sometimes the behaviours we reinforce, I had them myself, it's about yourself, me, and we tend to be selfish. And I think that's part of the insights, I guess, that working back, I think that when I was selfish, I probably actually was working against myself, and actually became more successful by actually being more generous with others, sharing things. Sometimes that you don't, you know, do I put this person's name on my paper? All those sort of things. And in the end, if you actually show a bit more generosity of spirit, share your results, share your laboratories, collaborate, in fact, you can get a lot more done.
Did you ever have one of those moments where you've been working hard on a problem and it just was not going to work? That was a dead end? What might be called box canyon research or something? Oh,
yeah, look, I've actually found that sometimes we worked on a problem, we couldn't solve it, we worked on it and it wasn't going anywhere, and we parked it and left it and then sort of moved on to other avenues. So let's call it a dead end, you know, almost. Yeah. But that dead end actually later on gave us insights into how to solve other parts of the problem. So you actually got insights into the problem. It's a bit like trying to, you know, approach a problem from one side, it doesn't work. But actually through that and actually doing that work, you actually pick it up. And then sometimes what also happens, using Hans's earlier point, there's some other technology breakthrough, some people have actually solved part of the problem a different way, and all of a sudden the approach that you had becomes valid. So very rarely have I said that we've wasted our time. You know, you actually, in the sense that you actually work out what needs to be done, you could have been done more efficiently, but the point is to learn the lessons.
Yeah. I'll come back to that in the context of doctoral research in a moment. But Hans, what didn't work for you?
Well, let me look at how close you stick to a plan. You know, I was trained to be pretty organized, to set up a research plan, to actually follow it. And there's a lot to be said for that. If you don't have a plan, you don't get anywhere. But in hindsight, many of the good research turned out to be quite different from what was planned. So for example, I did it myself and other students, they tried to make a complete drawing how this very elaborate table of optics would look like before they actually put the first component there. Sorry, it doesn't work like that. You have to have a concept, and then you have to be quite creative but flexible when you put even the complex machines there. So it might be counterintuitive for an engineer where you have a drawing first and then you build a circuit, but in some of the sciences you need to be quite interactive. In addition, there were 2 occasions where I saw something here in the lab early in the 80s which wasn't quite right or puzzled me a little bit, and I found a trick how to turn the 2 effects off. One would have led to the invention of the optical tweezer, which is now a big optical instrument, and I missed that completely because I put it aside as a dirt effect. The other one would have led me to atomic cooling with lasers, which got several Nobel Prizes, and I thought that was a real nuisance effect that I got away by misadjusting the lens and made it disappear. Now, I think that makes a really great scientist who would at that point said, that's unusual. I follow that a little bit, and I try to figure out exactly why it is, rather than making it disappear immediately. But it wasn't on the research plan, so we succeeded in eliminating.
But what is interesting to me, though, is that the research can't always succeed. That you have to encounter problems from time to time that seem to be good problems, or is some question to be answered, and you can't get there. And if you were doing it as a mature researcher writing a paper, you then couldn't write the paper. But as a PhD student, that can often be an essential part of PhD research, and you'd have to write up the fact that it didn't work.
Yeah.
Does that sound reasonable?
Yes.
Absolutely.
But as long as there's some other positive outcomes as well, it's not an entirely
As you said,
negative thesis. But I think if you had, I think that it's the insights that you learn. It's the lessons you learn from the conduct of the work.
And if it's an experiment, to describe what you actually did and how you came to the conclusion that it didn't work is as valuable as having a positive answer.
Absolutely.
Right? So it needs the same attention to detail in a way to document that.
And as both of you have said, I think the flexibility to change direction or to learn from that apparent dead end to change direction is very important. Thank you. Alex, how important has money been to success in your research?
It is important. I've actually said it, in some sense that when I came to, I previously, before I worked at the ANU, I worked at the University of Wollongong. It was a small university, and you had to really, to get ahead, you really had to get grants externally to the ARC and through companies, etc. So, and coming to the ANU in the research schools, it was a very nice environment, and you could actually get going and not worry about some of those things. Now, it was a privilege to work in that environment because you could quickly get moving rather than write a grant, wait a year, etc. But thinking back on it, in a sense, I do think that the asking for money is important, and being able to articulate your ideas clearly so people can truly understand what is the question you're trying to solve very clearly, and it's got value, and what will be the benefits of the work, and then how you'll conduct the work. I think that rigour is very important. And by actually, so that there is a sort of prize in the end, that you get this money that you can have. And the other important point, I think, when looking back, is every young person or young scientist needs to have a budget or a piece of money they control, and they're not going to a head of school or some other senior colleague, can you give me this? And you find, I think, you can get into a, well, it's not a healthy relationship, but you're not really going your own way. So I think that the money actually gives you independence, and that forces you to sort of articulate your ideas to people. And effectively, one of the biggest things we have to do as scientists is to communicate our results. And that sort of gets you on that road. Because sometimes if you're just given money or a blank cheque in a great university, you can just do the work, but then not necessarily write it up or just make assumptions. So that's my view.
There's a discipline around that as well.
A discipline.
Yeah.
But although I do still think there is value in block grants and things like that, but there is that bit that you need to get yourself.
Thank you. Hans? How important has money been to you?
I mean, it's fundamental. From one point of view, you can't do research if you haven't got the means to buy your equipment, to pay the students, the scholarships, and so on. So, that's a given. So it plays a huge role. In my game, you try to set something up in Australia and you feel like a maverick compared to Europe, because you know that if you are successful here with the ARC, your counterpart in Europe would have about 2 or 3 times the amount of money, let's say in Germany, to do the same thing. Now that translates into speed. So how are you going to compete them with being the first? You have to be really a maverick in Australia. That's sort of, so that was a bit of a limitation, but it was also a stimulation. So you wanted to be a maverick, so you became a bit smarter. And then you smile even more when you actually beat them to the challenge. So, it could be, hypothetically, that if money is too easy, you're also not quite as creative. So there must be some sort of an optimum.
Yes, that's right.
That, you know, it allows you to do the things, but it challenges you also to be effective. And
if I could just build on that point, Hans, it's exactly what I've just observed in my new job. And we have a program in hypersonics. This is, scramjets and
good old
rocket
scramjets,
science. It's the ultimate kind of frontier. And the Americans have got these programs, and they're building these vehicles which can fly at Mach 6, Mach 8. It's about 1.5 kilometres a second, very fast. And they've had enormous problems because they've tried to build the whole vehicle, and all these systems go, and there's a little part there called a scramjet. And even if the scramjet is working, but there may be some other parts of the system, they've had some spectacular failures. While the Australians, on the other hand, the guys out of Queensland University working with DSTO together, have developed this, an approach where they just do experiments. And the experiment is based on taking a payload, putting the scramjet in there, putting a lot of telematics on it, and putting it on a rocket, firing it maybe 100, 130 kilometres up into space, and then turning it around and bringing it back down and accelerating it to Mach 6, Mach 7, Mach 8, and then doing your experiments and doing your measurements. And it's all controlled. That's all you need to worry about. And in fact, and we've been doing this over a period of a year, this approach has completely leapfrogged the Americans. They cannot keep up. We are going faster than they can. And the program is at 1/10 or even less than 1/10 of the cost. And it's, again, I think when you give people a lot of money, they don't necessarily think smart. And the Australians have actually come up with a regime which is doing these shots, what they call high shots, and doing the measurements. And actually we're developing our scramjet technology much quicker. In fact, the Americans are now coming in and saying, can we be part of your program? So that's, I think, really re-emphasises that point that you made.
So what both of you are saying is that you have to have money, and you have to have in engineering and science research teams, but they don't have to be super large teams, and they don't have to be rolling in cash. Ingenuity is very important, and there might be an optimal size team for a given problem.
Yeah. Well, this team's in Brisbane's about 25 staff, but a fraction of what it is in the US.
Here's the hard question. What advice would you give to new researchers, people just starting out? Now, there may be people who are PhD students, except with PhD students there's a supervisory relationship, but the person who's now going to be an independent researcher, who's got to make their way in life, hopefully make a career out of it, and therefore have to be successful. So, Alex, what would you say to a novice researcher?
Okay.
And again, it'll be different in engineering and science and arts, perhaps.
I'd still give the same advice to, doesn't matter where what sort of discipline. Find the biggest problem you can find. Find the biggest problem that you think you can solve, and next, work with the best people you can.
But if it's the biggest problem, doesn't that mean there's 100 other labs around the world working on the same problem, or you don't worry about that?
I don't think so. If you've got, this goes back to this idea of set your goals low, set them high. I mean, it may be that, you've got to be, it's a realistic biggest problem. It's the biggest problem you can solve, but don't feel that you've got to shoot low. I think be bold. Biggest problems, and also the other important point is work with the best people. And I've sort of had the privilege of working in a number of organisations. I've worked in industry, I've worked in 2 universities, and one of the things you just learn that it's the people, best people. For me, I made huge inroads into my work when I came to the ANU and worked with people like Brian and Anderson and John Moore and others. It really made a difference. You actually saw how these guys worked, how they operated, the standards they set. You lifted yourself. And I think that's it. The best thing I would say to students, find the best people, biggest problems.
Let me just twist that a bit before I come to Hans.
Yeah.
So how important are sabbaticals?
Look, they're important. I think it goes back to this idea of, I'd say, working with the best people. Yeah. If you want to work with the best people, you go and work with them, collaborate with them. And one of the other things I also learned is that sometimes you've got to be, we're too humble, and you don't think, well, that person, they're obviously too great, they probably wouldn't want to work with me. And interestingly enough, I remember when I started my career, I met this famous Japanese professor in robotics, and in the late 80s, the Japanese were really making great inroads, and I was surprised by when I sat down and spoke to him at a conference. He was quite interested, and we started to talk about problems, and he was quite interested. And then before I knew it, he invited me to his laboratory. He even gave me an airfare. At that time, I didn't have the scope to travel as a PhD student, and that's the insight. And then from him, I then did some great work with him, and then moved on working with others, and that goes back to that point.
Yes. Hans, what would you give as advice to a novice researcher?
A lot of that applies, but let me add another dimension to it, maybe a bit more personal dimension, and that would be the advice to finish whatever you started. You know, there's lots of people who can start things, but what really matters later on is what did you do with it? What did you finish, completed, published, communicated? Give yourself a break. Think again what the new direction is. Don't rush into the next problem immediately. Start something, and then you see, and I think you find it in the pattern of most successful people, the careers are not planned. If they had a plan at age 20, they probably did something completely different. Stage by stage, but it's a succession of things you completed in your life. Your degree, your PhD, your postdoc, your first project. And if you take that seriously, I think you have a big advantage.
Right. You know, I think a lot of people who reach retiring age think they need to write a book called Unfinished Business. It's to pick up all those projects that you didn't quite finish.
Oh, no, don't do that. Come on. Have a new, fresh problem, right?
When you talk to a young person or giving a new researcher good advice, how do you advise them in terms of the balance of what used to be called inspiration and perspiration? Yeah, how much good research is really insight and how much is really just doing the hard yards?
Well, that's a hard question to answer, John. I just wanted to just go back to the points that you were just making about, you know, the work about doing things and getting things done. I've found that for me, and working to a 5 to 7 year horizon is a good chunk. You can actually get something done in that time. When I started off, I was also just exactly didn't know. I joined BHP. I thought I would be an engineer in BHP. They gave a great cadetship, and things changed. Did 6 years there, but in that time I was able to work on a hot strip mill automation, one of the big automation projects of a steel mill, and I learned a lot out of that. But I completed that project, and that was the point. And then off to do PhD, 5 to 7 years. Even that time I spent at CSIRO was about just under 8 years. My time at ANU is about 8 years, and you find those sort of chunks. I think you can actually get something done. But the other important point is to actually have that variety. If you work in different places, a big takeaway for me is that, you know, this idea you can. When I first started my career, when you joined BHP, and BHP never recruited a CEO or a superintendent or an engineer. Everyone came in as either an apprentice or a cadet engineer or cadet business person, and you just worked your way through, and you had a career for your whole life. But I think these days it's a mobile, knowledge-based workforce. You can go to places, and I think I really do encourage people to be a bit more mobile. If you're mobile every 12, 18 months, you don't get that point of finishing something. But I think actually going to working with the best people you can find and doing those big sort of substantive bits of work over a period of time, be it also international, outside of Australia, is a good thing.
Yeah.
So I did answer your question.
No, that's good. I agree with that. I think there's a huge benefit in good sabbaticals because you get to meet the key figures out there, you get to network, and you suddenly find that the key people are very humble people and very engaging and very sharing people. That's an important part of it. And I think the other thing sabbaticals teach you is that even though we're out here in the Antipodes, we're just as competitive as the people in the big research labs. It's come back to Hans's point that you have to be a bit more innovative out here because you don't have the resources and the huge teams.
And I think to me a sabbatical is, you know, it's not just going away. It's actually an investment you make of your time. And time is a very rare commodity to work with someone else, and they honor that.
Absolutely.
And then it becomes reciprocal.
Yes.
Then you suddenly can invite people to actually do the opposite, and that's how the true interaction happens. You know, but people realize you're making an investment in being there, being part of it.
Absolutely.
And that's, I think, is sometimes overlooked.
Yeah.
You can't do that on the email. You can't do that by normal communication or a chat on a conference. You have to make a real investment.
That's true. And going back to
Until
that...
teleportation works.
That's right.
Until then, but I think you're on a safe ground there. So.
But that business about inspiration, perspiration, I think it's both. I think a lot of people used to say to me, geez, you're lucky you've got this company. And I thought, after a while, I used to say back, it's funny, the harder I work, the luckier I get. And in the sense that I think if you do the hard yards, it gets you to be in a position to be lucky. Because in the end, there is a lot of luck in business, because you've got to have the right technology for the right markets at the right time. But to be there, you've got to do the hard work.
And you have to seize the luck.
Exactly, and you've got to seize that moment. So I think sometimes it's not just having a brilliant idea, you've got to put the hard yards in.
In fact, it strikes me when you take a research concept through to production, the inspiration part is almost minuscule. It's that hard work you put into the other bit. Alex, your comment about the 7 to 8 year periods is very interesting, because I mentioned my PhD supervisor before, and that was part of the advice he gave me. He said, never stay in one position more than 5 to 10 years. That sort of 7 to 8 year period is about right. And he said, if you want to maintain vitality and productivity and being contributing to the world's research developments, change what you do. And as you say, 2 or 3 years is far too short.
Yeah.
Or you might take on different roles. I mean, I've been here for 30 years, and you could say that's pretty dull. But my function, my roles here were quite different.
Correct.
From starting groups, running groups, setting up centers, head of department, which is the personal aspect, mentoring people, and now I've handed it all over. I mean, that's you have different parts of your life where you're doing different roles, and then I think the sort of 5-year interval again applies. That would have come in you on top of changing location or company. Yeah. Also, your role would have changed.
That's true.
Every time.
Roles change, yeah, that's right. But although I always felt I was a research scientist, in that.
Yeah, but I mean, what you do day to day.
No, day to day is
through
different.
other people. Right?
That's right. That's right. Yeah.
Through other people.
Here's the dangerous question.
Yes.
What irritates you? Now, lots of things probably irritate you, but what irritates you in terms of research, or people's attitudes to research, or what does work in research?
I think there's this sort of. I think we talked about good people generally are humble, and I think there's that you meet in my game, you meet a lot of people, and I do come across as a case quite often as a case of a sense of entitlement. Because I am a PhD qualified person, I should get this, or I should, and I'm entitled to this, and that I think that's just I think privileges we really are privileged to work in research universities and in research institutes and be paid by taxpayers' dollars to do great work, and I think we have to really appreciate that investment by the public in us. And that means you've got to really do your best and not just expect that things are going to be given. And there are people, unfortunately, who don't really appreciate it, and they have this sort of quite needy or demanding, and I think can't see how if it's not for them, they can't see the bigger picture and how things fit in. So I think that's the kind of thing I think you've got to, while you've got to be single-minded about your own work, you've got to be also self-aware and see what other competing priorities are there with you. And are you just putting more pressure onto your colleagues by being more demanding, more selfish?
Thank you. Hans, what irritates you? Is it different in different fields, or?
Oh, that applies in my field as well, particularly when you go broader and have bigger centers and have multidisciplinary things. There's another thing, my patience for bad communication is just dropping and dropping. A bad lecture, a conference talk that doesn't come to the point, people who can't summarize and actually express what they're doing. That irritates me. Time is very precious, and I think good communication is pretty much up there as a skill which you need, which you can learn, and which you can optimize. Yes. So get out of these modes where everybody is just, I wish this was over.
And there's a couple of interesting lessons there. One comes back to what Alex said earlier about grant writing, that the the discipline of grant writing is really a communication discipline in some ways. You're selling yourself and you're
That's right.
communicating.
Absolutely.
And the second lesson is picking up again the point that Alex made about public money, and in fact most of us do our research on public money. The inability to report results or the unwillingness to report results. You hear so many people from time to time won't publish because it's just too hard.
And put them in perspective, put in what other people make with the results. Right?
Yes.
It's important.
Because we are all part of the world community of scholars, and I think it's incumbent on us to share, and you do that through your communication. So I can understand that sort of frustration. I always feel sorry asking Alex the first question and you the second one. But
That's all right. He gives good first answers, right? So.
This one won't make any difference, I don't think. I don't think it would. Alex, at your stage now, where you've been through a very, very stellar series of steps in building your career to where you're now very much involved in research management, there must still be things that you would love to do in research yourself. You'd like to get back to the lab and onto the bench. But so the question is, what's on your bucket list for research? I don't know if everyone knows this term bucket list. It means what do you want to do before you kick the bucket, which means when you die. So what research do you want to get done, or would you love to get done before you
Well, I guess that
move on?
Personally conduct the research is another challenge, and I kind of do that on my own anyway. Sometimes I tinker around at home because at the end of the day, being a scientist is it's a hobby.
Once a scientist,
and you actually get. Well, the great thing about our jobs is we get paid to do our hobby. So I do sort of like to read about what's going on in my field. I sometimes even look at a bit of play with a bit of software. I'm very interested in computer vision, so I still sort of tinker around and kind of keep a watching brief on that. But one of the privileges I have in my job is that I can actually direct projects into where I think we need to make breakthroughs. So I still think that while I'm not personally conducting the work, I can motivate people to say, we need to solve this problem. I need this team to help solve this problem for Australia or for whatever. And we can actually start to steer work into various areas. So in a way that what's on my bucket list, I'm trying to push. So even inside DSTO today, I believe there are some important technologies. For instance, cyber technologies, cyber security. It's undervalued by Australia. Huge potential threat to us, and we need to be very careful about that. Things like autonomous systems. And these are the areas that are underdone. So in my current institution...
You personally would like to get involved?
And what I'm doing is I'm making sure that the dollars are put in there. We attract the young leaders, we resource them, they get to do the tough problems. And so in fact, they're working on the problems I would have worked on. So I feel very happy about that.
When does the time come where you can make more contribution through research management than doing the research yourself?
Well, it becomes very quickly, it's if there's two people, you're already, you've got to be twice as good as the other person. And if you're in a group of 10, so you get 10 times better, it becomes very easily, you quickly see that you've got to be working in a team-like environment. And occasionally you can be providing insights and inspiration, but one of the things you've got to do, no matter when if you're the leader or the person who's got the more experience, occasionally people in your team come up with better ideas. So you've got to create an environment where the best ideas always win, no matter who they come from.
Yep.
And you've got to be humble enough to say, I was wrong, that was not wrong, but maybe you've got wrong insight, let's go this way. And I think if you have that humbleness to be able to accept this prospect of others innovating and doing the leadership and even if it's a younger person, that's very inspiring. I think it's very fulfilling. So you don't have to worry about this bucket list because we're all in it together.
Right. Hans, what would you like to do still? Like, you're very much into science education, science communication.
Yeah.
You're still a physicist at heart.
Oh, sure, yes. Lots of things. Well, let me start on the topic area. I think what is unique in the moment is that all of these big challenges are quite complex systems. And now there's whole research areas, centers of excellence in complex systems, I'm aware of that. But there might still be things we haven't actually figured out. There might be approaches to how can we understand biological, physical, and even human interaction to be better, to understand them and possibly even take an influence. In my own work, okay, you mentioned this teleportation. Well, that was a great trick to get funding 20 years ago, and you really get noticed when you put that into the newspaper, and it was a bit more there. It was serious research,
yes.
And it still is. The open question there is when you take all of these machines which we developed, and you can actually put them into small things like a remote control, and they're all going to be integrated, but what are they good for? We haven't actually answered the question, what are the technical applications? And there will be, I have no doubt. But I'm not convinced that, for example, the role of quantum mechanics in biology, what people propose in the moment, is actually realistic.
Right.
There might be links, and so, so I can see a huge horizon. How to do this? Well, exactly like you said, Alex, you work for other people. Now, I'm not in a management role. I don't set priorities. Sometimes I'm at ARC, so you make a bit of a selection. But most of the time, I challenge people directly, PhD students, individual, even teachers.
Yes.
What are we going to teach? What are the next generation going to learn at a school level so that they have the best preparation to then learn at a university level? With these big targets in mind.
With Alex going home and tinkering on the weekend, I was going to say in the garage, but it's probably in the office on the weekend.
On the laptop.
You don't like to solve Schrodinger's equation with different boundary conditions?
No. I go soldering. I build my own house. I try different alternative heating systems.
Oh, right.
I'm the hands-on solder and practical guy at home.
And you don't worry about the orbitals and the solder or anything like that?
No. But there are clever solutions we have found in energy that are just not implemented, so why don't try them out on a small scale?
Excellent.
I don't like how we do desalination in a brute force attempt in using electricity and driving high pressure pumps. There must be something much better, and I'm tinkering a bit with that. Are there other ways how we can optimize desalination?
So this is really great, because it means you're still thinking about those problems that are driving humanity.
Yeah, but I'm not an expert in desalination, but it's great fun to do it.
But the intellectual drive is still there, and that's important. Yeah. So this is probably a question that we should ask the others rather than ask you. But who do you wish you had chosen to work with? Has there been some sort of void in your research career where you said, I wish I could have worked with so-and-so at Stanford or so-and-so at Cambridge?
I actually was probably, if you'd asked me 20 years ago, I was probably maybe felt like that. Yep. But in the last, part of my, I've sort of had I got the self-confidence to go and just work with who I thought were the best people and just seek them out and talk to them, partner with them. And sometimes they're not interested in working with you, or you don't get on with the person, or you just got different interests, or the phasing of the work doesn't work out. That's okay. But always seek to work with the best, and I have no regrets in that regard.
No lab in the world that you wished you would have had a chance to?
Oh, well, if I had more time, I probably would have liked to. There's always, you've obviously wanted to do that, but the ones that I really wanted to work with, I did.
Yeah, good. Hans?
Yeah, very similar. I mean, time was the limit.
Yeah.
And you couldn't fit all the things in you wanted to do. Some connections would have been extremely valuable, but you have to make choices. So, yes, there could have been more, but not with 24 hours per day.
That's right.
So,
would you want it to have been somebody different?
Be someone else.
Would you have liked to have been Brian Schmidt and discovered the accelerating universe?
Look, I'm very happy being myself, and I think that one of the things, I'm always inspired by people like Brian and others, and I've always been one of these people who like to read autobiographies of people like, variety of people like Mandela or even Thomas Edison, and just seeing what these people were like, and I think they're great role models, and you think, well, could I do something like that? So I've more or less been more inspired by others' achievements to keep myself, to nose to the grindstone and keep trying to do the best you can be. I think that's all we can do.
Did one be Einstein?
No, not really.
No.
No, I think if I really want to finish big, then I would say it would have been great to think, what would you have done at a situation in society when things can really change? You know, when you have a charismatic person actually changing the way people think, let's say in education. I wasn't here, but you know, Whitlam you read a lot about. You know, what would you have done if you had been in that position to actually make big changes? We have similar thing in Germany, Schmidt as chancellor. Or what would happen if you had been in Steve Jobs' position?
That's right.
You could actually do that. Well, that's amazing, right? So yes, I can dream about that. I'm not sure I did a better job than they did, probably not, but you know, that's certainly worthwhile contemplating.
Yeah. The job story is an interesting one because you've got a very driven person.
Oh yeah.
And a person who had such precise ideas about what had to happen, whether they're right or not, just had to happen. And
so that's the type you're really frightened about, right?
Yeah.
I wouldn't want to be a Steve Jobs like that, but the vision,
the products are great.
Yeah. Or the vision you had and the understanding.
Yeah, the achievement, vision, fantastic. But a lot of people don't say he was a good person in terms of a nice person to be with, and he was a terrible boss, and you know, could be a bully and all that sort of stuff. So. You know, I would never trade off to be that kind of person to get that as sort of achievement. It's not, if that's what it means to do an Apple, I wouldn't want to be that kind of person. But I must say I'm inspired by what he's done, and it's just that whole, you know, and the way he left his company, then he came back and he had all that. But that's that pursuit of excellence and putting in the hard work. And I think you can do that, and you don't have to necessarily be. Stop being a nice person.
And I don't think he will have a great legacy in people who actually learn directly from him as a person. That's sad, right? So I'd rather be in a position where you actually have people who follow and take directly from you.
No, I think Jobs was the right person at the right time for that company from what it did. Alex and Hans, I just want to ask a question that's not on here, and you won't have thought much about this, I don't think, but if you go back to the 16th and 17th centuries, you know, some of the science breakthroughs were made by people working in their own homes. Often they were ministers of religion, you know, they were people like Galileo working on their own and so on, and they could do that. And we've been through, in science especially, we've been through a period in the last 100 years where you simply couldn't make big breakthroughs unless you were part of a huge team with a big budget, or a modest team with a modest budget. Yeah, but you had to be in there with a group in a laboratory in order to be able to do the work because you needed that machine or whatever. Alex mentioned a while ago that he tinkers with things at home, and that's made now possible, I think, at a very high intellectual level, because information technology means you can get measurable access to information out there, research results instantly. You can get software on your computer at home that you can now produce research results that you could have dreamt about 5 or 6 years ago. And it intrigues me that you start now getting the citizen scientist, the person who may not have the formal educational training, but nevertheless is intellectual enough to make contributions to society at a high level. And I just wonder whether you would have any reflection on that. And it all interlinks with social media as well.
Yes. The internet and the wisdom of the crowds is an interesting phenomenon. I think this idea of crowdsourcing is a interesting concept. I mean, there was an Australian company, I just can't remember its name, would have had to look it up, but it's basically the idea, what it does is for prize money, it posts up a problem. It's usually in the mathematical, statistical areas. Here's a set of data, can you find a good model to explain this? And then they run your algorithm against some unseen data, and in the end the person who solves a problem wins the prize. And you know, when I was working at CSR, quite a number of my mathematicians that used to moonlight on that site trying to solve those problems, and some of them did okay. But interestingly, when we go back and have a look at some of the people who solved the problems, they were not like one person was on there and kept cracking the problem.
Yeah.
It was actually a variety of people, and generally the person came from a slightly different background, and they kind of tackled the problem from an unusual way. So this is this idea of interdisciplinary problems, and sometimes they come across and solve these problems, and they've been able to, you know, do better than, you know, the banks are trying to work on what's an algorithm that predicts loan default rates, and they could do no better than 70%. Put the problem out, someone out there and came up with an approach, and 85%. Right. And that kind of, that's at your backyard tinkering, because you've got the tools, the platforms, you can do that.
And I think the social media to get.
And the social media aspects. And so the next question, of course, these are individuals. Could you actually get teams of of people now who are not actually working together, but somehow in the same institution, but they're distributed and they come together to try to solve part of a problem.
Or international teams.
International. And there's been some, part of that work has now been going on that concept, as I talked about crowdsourcing, is trying to map, DNA or unravelling genes, and people from different parts are coming on, spending a bit of time, trying to tinker with the problem, log off, next person comes on, and actually solving quite complex problems in this way. So I actually think this concept of the backyard scientist engineer is still alive and well, but it's just morphed into sort of cyberspace.
Thank you. Hans, do you have any comment on that at all?
Yeah, actually quite a different view on that.
Yep.
And I actually don't quite agree with the picture you painted, how science has progressed. You're perfectly right what it took to go to the next level of complexity on machinery and designs of items which we use. They needed all of that. But I find when it comes to the big progress or the not so predictable progress, it's still the creativity of individuals. Mm-hmm. And that's, I think we don't know much about that. The tools might help, but I worked for a while, for example, at IBM. That's a big company in the 1990s. And when you work in the IBM research labs, you see how there are individual people with very quirky minds still coming up with the next big solution. While everybody is busy that way, they're thinking diagonal, and sometimes they come up with this new idea. Now that will continue, whether the social media and the big computing power we have at home actually helps. I'm not convinced yet.
You're quite right. I think that the intellectual endeavour of the person is implicit, but there's a multiplier, I think, that we get through the...
We might find about them earlier. They might be able to test their ideas more quickly. Right. So the cycle time, but the fundamental effect that we need these individuals, I think, is still there.
In fact, so I just add to what Hans was saying, John, is that absolutely agree with you. And in fact, where you find you can have the individual working is when they're branching out into a new area. Mm-hmm. Once you're in the mainstream, you can't compete with big groups and big budgets. If you're a pathfinder finding the new areas, you can be an individual. Because if you are truly original, you'll be the first person there, blazing a path, and you can actually make the early fundamental contributions.
Isn't that why we set up universities? Yes. To have these quirky people, give them a means of actually being creative?
Yes.
Maybe we're not doing much of that. Or enough.
That's probably a good discussion for another occasion.
That's right.
Colleagues, I think we probably have exhausted Alex and Hans in terms of the set questions, but we've got to give you the opportunity as well. There might be questions you'd like to ask the two of them. So now, for the next 10 minutes or so, it's over to you if you have questions you'd like to ask. Anything at all to do with research or research training?
Who's the icebreaker?
Thank you.
I'll break the ice then.
So I think there's a mic.
We have a microphone here.
There's a microphone
This is a very dead room acoustically. You will need the microphone.
It's recorded, so you need to be on mic.
Is that okay? I wasn't going to ask a question, but a number of science commentators talk about the way science is done is by, I guess, doing some reading and then making hypotheses and then testing the hypothesis. And that's totally foreign to my total experience, where what I've been doing is trying to find the answers to things. What is going on here has been what's driven me the whole time. How do you two react to the idea that one sets science is done by setting a hypothesis and then testing it?
That's the sort of standard model of science method, isn't it? We'd better ask the scientist first.
Well, I think it actually applies, but we hardly ever use these words, nor do we train people to do this. I think we probably do this many, many times in small steps.
That's right.
So in your work, you would also say, what if I frame it with this equation, or I put these data in there, what would come out? It's not the big hypothesis you might do in medicine. This illness is based on that, and now I have a whole study, and how do I design a study to prove or disprove my assumption? I think in the type of science I'm doing, it's done more frequently and in smaller steps, but it's very similar.
Alex, engineering research?
Yeah, I'd agree with that.
Yeah.
And in fact, with computers, you can do many, many experiments very quickly and change a piece of software, run the experiment again. So it's really just a very tight loop, I think, on that fundamental hypothesis, but you're kind of being driven to understanding something or showing something is possible. And then through that, through a series of experiments or physical understandings, you actually unpack that or unfold that. So I think the fundamentals, the method is right, but it's just done in a more iterative and smaller steps.
Or in some big step.
Or big step. It can be big steps, of course.
No, where you say,
yeah, sure, hydrogen
it
collider
takes
or
me 4
something.
years. No, sorry. I might take 4 years to set up an experiment.
Yes.
And that's what I expect to happen when I have put all of these things together. Your high flyer, it takes probably several years to assemble.
Correct.
But you have a clear idea what you're testing.
True.
You had a follow-on question?
But that approach, though, is based on multiple little steps,
absolutely.
even though each one of those
is
complicated. Yes, that's right.
Yeah.
I guess I work more in theory, and there it's, as I say, I think my experience is more, sometimes there's a hypothesis, but usually it's what is going on here. I just want to understand whatever it is that I'm looking at. I don't understand it. And by the time I can formulate a hypothesis that might turn out to be right, then I've pretty well understood it by then. So,
Okay,
so the problem's almost over.
Thank you.
But that's in theory.
The root for the word engineer is also the same for ingenious, isn't it? There's one over here, Melanie. Thank you.
Yes, if I try and pull together 2 or 3 themes, particularly the last one about different ways of doing science, Alex's comment about having research that might contribute to society, and then different ways of bringing together insights, ideas for a problem. You may be aware of the Gates Foundation approach to problem solving, which allows anybody to have a go at solving a problem. They present a challenge. Their big challenge at the moment is to design a toilet for the several 100 million people in the world who do not have access to their own toilet. And they've set a number of parameters in terms of cost and sustainability for this challenge. And they provide amounts of money of $100,000, for instance. And they give out those grants to maybe 100 different applicants. And those people don't have to be in any formal institution. They don't have to have CVs and have impact factors or, justify their credentials. They have to have an idea and demonstrate some capacity to follow up that idea. Gates has been doing that with a number of problems. Clearly these are quite specific ones, but it doesn't seem to me, although people keep posing this idea of grand challenges, we don't really have any big grand challenge competitions.
Do either of you want to comment on that?
Oh, look, I think that's right. I think it goes back to that idea of open innovation and challenges. So, I mean, DARPA in the US has been running those for some years with the grand challenges for making cars drive autonomously on roads and offering $1 million prize money, and they got universities and teams and research institutes which spent probably $200 million collectively to win that $1 million, but in the process have actually advanced the technology. So I think the challenge approach and offering a reward, sometimes you give out grants to keep people going, but in other cases research groups come together to try to solve the problem, and the competitive aspect of trying to solve that through various approaches has been done. So it is now recognised as a form of innovation model through setting a challenge and offering prize money.
My recollection is that Microsoft do much the same with their staff in their earlier years. They'll take a number of staff and ask them simply to go off and think about problems, and then at the end of that year come back and see who's succeeded or who's made good progress, and then start filtering their staff out for later projects. Hans, did you have any response to the comment?
Yeah, I mean, I think it's a great idea and it has a place, and it's good to have people like Bill Gates and others who actually put their resources behind it. I think it fully has a place. It won't. I don't think you can solve all the challenges with that way. No. But what worries me more is is there is a lot of good solutions that have been thought up but have never been implemented.
That's true.
I mean, many more of our challenges, we actually have technology. We might not be able to put it together in the correct way, but we have components of the technology. The challenge is now, how do we actually use it? How do we convince people that it should be used? You know, your practical example might come up with a device that actually functions, but who's going to build it and fund it and install it? You know, I think there's also a weakness there.
Thank you. Colleagues, one last question perhaps before we conclude. Is there one there? I can't see behind the camera.
So I'm interested in where you see universities in the future. So there's been much debate or much in the news about things like these massively online and open courses.
Yep.
Particularly, Hans, you've been very involved in education program. Is this a serious disruption to universities? What do you see as our future?
Wow. This is going to be recorded, is it? I think, first of all, it's an opportunity. There's a new mode of communicating and tapping into resources that are somewhere else, into people who present things and ideas and so on, that we haven't had. So we obviously should make use of it. Will it disrupt our business? I think it will. And it's easy to see that it will be dominated by a smaller number of players. Okay, so you have to be part of the game. Does it replace the type of human interaction we have in a university? I don't think it will. So if you had a degree solely built on sitting on your computer screen and watching it, I don't think you get the same as in the interactive mode we can provide. So that means the university have to focus even more on the interactive part, because that's what they can do. So I think the pendulum will swing to what do you do in a classroom, who is your lecturer, what is the interaction, to complement what you can find on the big wild world and what people are marketing. It's not easy. It might not be the most profitable model. It might be costly. So that's always hard to implement. But I think that's where it's heading. The university going back more to focusing on the human part of education, complemented by the information that is available.
Alex.
Yeah, it's actually interesting. I've sort of been watching this with interest. Actually, one of the big movers in this space is a guy called Sebastian Thrun, who's a robotics professor from Stanford, who's a friend of mine, and he went to Google to work on the Google car, and then obviously moved into other things. And so he offered his machine learning course online. It was that 140,000 people enrolled, and there was a breakthrough. Now he's gone off to start this company, Audacity. Mm-hmm. And I think my view is that, you know, he's backed by a lot of serious money. He's a smart guy. He's actually worked in these things. And I believe that the university sector generally is probably not really realising the revolution that's under play here. I'll draw the analogy of the music industry. And what happened to the music industry, and what happened to this idea of how it changed the whole business, and what we've got with iTunes and that kind of thing. There will be some sort of business model will emerge, and I think it will actually sort out and we will see more virtualization of institutions. I think that, of course, the traditional ones will be around, but they'll have to adapt to this, and I think this idea that, you know, we have to be in a classroom and to do the lessons, etc., is different. I had two sons who finished university. I saw how they worked, and there's this idea of going to always being in a lecture wasn't there. They get their friends to do things. Now some of the lectures are posted online. My own daughter, she's a teenager. She has never received a letter in her life. She's only reads email. So she's in front of her computer. For her to actually receive her lessons or educational content in that way, I don't know whether that's going to be such a big limiting factor. If she can interact with people and get answers to a question, can be tutored, can get access to a brilliant professor like Hans, would it matter? And I'll just make my last point, is I think that this is being underestimated. I think Australian institutions particularly are saying it won't matter. And I think what's going to happen is this is a a revolution which is going to globalise education, and I think truly globalise. The internet is a globalising internet. At the moment, it's been captured by geography, and now these courses are going to go everywhere. And if you're not in that, in a consortium or part of it, you're going to be left behind. And I think this is, and I think the American universities are already, the leading ones will be there. They'll be using it. It'll be a way to augment their programs. But I think if you're an Australian university which is not right up there, like the ANU is, but if the ANU ignores this, it could be left behind.
But I think there's an opportunity.
Of course.
Because that course was
Yeah.
listened by 140,000.
Yes.
The person could not possibly, even with the fastest email, answer 140,000 questions. So there's some smart components missing, and we could be one of the leaders in the world. Yeah. How do you combine this mighty power of the distribution with the interaction part?
They are, in fact, they're using these methods now, which I was surprised. That was, I think, is the fundamental problems. But they're now breaking groups up into sort of clusters, and you kind of tutor yourselves or discuss the problems. It's through those discussions.
The Open University in the UK has local tutors, even though it's a mega university.
Yeah, so I think there we need to be active.
Yeah.
And we could take away from that.
We could talk about this all
I just want to add my sixpence worth there, if I could, and that is, if you go back 800 or 900 years when university started, they started so people could come together and listen to the gurus in the area, the people who are the experts. And with the printing press, that you could actually start spreading that knowledge out and have other universities and other centres, not necessarily the expert. Now with the internet, you can connect people back to the expert again. Yes. And I agree with Alex, but also agree with Hans that there's a socialisation aspect that's very important. We're going to try and keep hold of that somehow. But I think the danger for the traditional university model is that if you rely upon the fact that you're going to have only local experts, you'll fail. Because the internet means you can connect with the top people in every field around the world, perhaps at a price, but why wouldn't you pay that?
But it may be a very low price, which actually goes right below what it may cost you to maintain a physical, huge infrastructure. So this could be quite revolutionary. I don't know how it'll go, but I predicted something would happen in the music industry. Unexpectedly ended up not what people expected.
Sure. Folks, we better call it quits there, and I just want to finish up by saying that we're an enormously privileged occupation, being academics and scholars. You know, we have this tremendous privilege of imparting knowledge to the generation behind us, and we have this tremendous privilege of creating knowledge through our research. Not always easy, and that's why it's been very good to listen to Hans and to Alex tonight, who are two long-standing researchers with tremendous reputations and tremendous experience. And would you please join me in thanking them for the benefit they've given us today.